Hello friends, here we are going to discuss about the magnitude comparator. So on completion of this topic, the students will be able to study the methods used for optimizing the adder and what is the worst case delay of the ripple carry adder. So here you can see about the digital processor. It consists of the input, output, memory control and the data path. So these are the building blocks of the digital architectures. One is arithmetic unit, memory, control and interconnect. In that arithmetic unit, you can be seen about the bit sliced data path, which we are having the adders, multipliers, shifters, comparators, etc. And in the case of the memory, you can be seeing about the RAM, ROM, buffers and shift registers. In the case of control, you can see about the finite state machines, PLA, random logic, counters. And interconnect, you can see about the switches, arbiters and buses. So in the case of the Intel microprocessor, you can see about the 6 integer execution units where you can have the clock pulses. You can send the messages through the data path so that it can be transmitted to the building blocks which we are considering as in the architecture. So this multiplexer or adders which we are using here will be connecting all these values into the register so that it can store the values in a register as well as it can send it to the data path. And here while we are sending the data in the bit sliced pattern, it is containing the registers, adders, shifters and multiplexers. It will be sliced into 3 different parts, that is bit 0, 1, 2 and 3. So when data comes inside, first it goes to the register, next it gets to the adder, shifter and multiplier, and then these are combined together to form a data output. So here you can see about the iterative integer data path. It is just a model. And the worst case delay is linear when you are considering these bits, that is when you are transmitting the input to the data path, the time which is taken to propagate to the output, which we call it as the worst delay time, and this propagation delay is the worst case over all the possible input patterns where we can see about the A, B and C value where we can set it to the worst delay formation. And here we can see about the major thing is the delay which we are giving to the adders or whatever the input which we are transmitting to the data paths can be formulated in such a case that it can be stored in the registers. Also when we transmit this data to the registers, it can be sliced into the bits of 0, 1, 2 and 3. So when it is transferred to the pattern of our bit to the 4th bit, there it takes some time because this data path has to transmit the data with all the requirements which is needed to transmit in the data paths. So these are the patterns which we have been using in the propagation delay. So we have developed into 2 parts, that which we call it as the propagation delay and the linear worst case delay. So if the data is transmitted or received in the worst case of the delay, so we call it as the propagation worst case delay, and which is very critical, and also it is used in the case of all the possible input patterns. When we are changing the input value for A, B and C, these inputs will propagate in the different patterns. So this is the quiz questions. What is the propagation delay of the n bit carry adder? Thank you.